Richard Ward is CTO and founder of OrbitsEdge, an above-the-cloud computing company bringing the computing power to the orbital assets and reducing the burden on downlink capabilities, alongside the inherent latency that such round trips add to mission-critical tasks. Rick has spent significant time in the UK and knows our industry as well as his own. This is going to be quite a long episode where we just chew the fat really over some of the big issues and news items facing the UK, US and global space industries today. I always learn a huge amount from these chats, and I hope you will enjoy joining us for that journey too. Richard, it's a delight and an honour to finally sit down with you for a chat in a way that we can actually share. So thanks for joining Giant Leap. I think we're planning to make a start by discussing the space tourism race that has been reaching a bit of a zenith this week. But before that, would you like to sort of critique my introduction?
No, it's pretty good. I haven't actually been to the UK. My VP of engineering is Ross Tierney, and he is a British citizen who's been living in the US for quite some time because he was also interested in the space industry.
Yep.
When he came over here, there wasn't as much stuff going on over there as there is today. If he was, 20 several and interested in space today, I'd like to think that maybe he could stick around instead of having to come over here. So, yeah, I've been interested in the space industry for obviously my entire life and involved in it for since 16, I guess.
Uh-huh. So what at 16 was you getting into the space industry?
Sorry, I meant the year 2016. I wish it had been my age of 16.
Well, there are some up-and-comers now, especially over there, actually. There are some up-and-comers who are building sort of thrust-vectoring model rockets and stuff, and they started pretty young, those boys.
Those are fantastic, and I'm not generally... I try not to be envious of people due to the year they were born, but the tools that are available today are
incredible,
freaking ridiculous. You can learn how to do lots of things with Raspberry Pis and the thrust vectoring rockets you were talking about. There are guys landing model rockets vertically from where they launched them. And that is, you can look at what they did on GitHub, and they're building all this stuff. They're 3D printing the rocket bodies. They've got the actuators. They're kludging together the hobbies of RC airplanes and rockets.
All sorts. Yeah.
They're doing this stuff, and they're getting paid for the views. They're also effectively making a fantastic CV, and it's amazing. I mean, you can
absolutely
you can see the future that these folks are building for themselves, and it's due to the fact that everything is networkable.
And it's entertaining. I think their journey is entertaining. This is a huge shout out. I think we both know that we're talking about Joe Barnard from BPS Space. That's BPS.Space for anyone who wants to go and check Joe's work out. He's all over Instagram, and he's pretty incredible. And and he started his journey. He wanted to become an engineer at SpaceX, I think. And he thought, I don't know how to do that, so I'm going to go and learn some of the skills that I think SpaceX must have. It's going to be super easy. I'm going to get a model rocket and land it like the Falcon 9 or something. And he's been through this amazing, incredible, difficult journey. But he's done it, hasn't he? He's done it, Rick.
Not going to build their skills. I'm going to rebuild their program at 1/100th scale or whatever the scale is that he's using.
Yeah, by myself.
It's fantastic. Yeah, I'm just going to replicate a scale of what a company does.
I mean, well, how does that feel for someone like you who's in a different but crucial part of the sector? How does that feel? Because, someone like Joe maybe is coming along in 2 years' time who becomes interested in in the comms segment or the data segment, or an amalgam of using all of the tools that are available to teens today the fact that the cost to orbit is plummeting at the moment, and we could quite easily have teenagers with actual assets on orbit tinkering around in low Earth orbit in 5 or 10 years' time.
No, I mean
We do already.
Some of those teenagers have been doing that ever since the time the first kid bought a weather balloon and strapped his iPhone underneath.
True.
You've had that. They're just getting more sophisticated with their backyard efforts. So there have been, over the past several years, older people decrying the lack of skills found in the young people. Okay, yeah, there's some who don't know how to change a tire. But on the other hand, there's kids who've essentially built their own space program with very little information other than what they've built. And then what they have built generally has gone into some sort of a repository so that the next kid can do even better.
And I think it's that collaborative approach, isn't it? I mean, that's a golden thread, to be fair, that's run through space programs for the last 100 years. Let's go post-war, but kind of information sharing among allies. And okay, there were two big camps, and there are still perhaps two big camps.
It's a tremendous time to be alive. It's not just those things. You've got Kerbal Space Program, which is a game.
Huge fan of that.
But accurate physics, so you can actually plan real live missions to Duma and Moon, and if it worked there, it'll probably work here. And we've known how to do all of the fantastic things of space travel. We've known how to do those for 50, 60, 70 years, depending on the thing.
Yeah.
We've had plans that would work for a moon base, or for a spinning O'Neill cylinder, or for how to do space mining, or outward bound ships to explore other solar systems.
Yep.
The issue has always been launch from Earth. It's always been LEO. And it's
just such a gravity well, and perhaps just before we get too geeky about this, the reason we're about to focus on LEO being such a barrier, by that we mean low Earth orbit, is that the Earth is this really awkwardly, almost perfectly dimensioned object where the gravity is so strong that it's really hard to get to orbit, and the atmosphere is so thick that it's really hard to break through the atmosphere, and only the best chemicals, when you combine them, have enough chemical propulsion to lift themselves and a useful payload from the Earth to space. And if the Earth was just a little bit more massive, or the atmosphere was just a little bit thicker, we would not be a spacefaring species yet. Yes. And that's really, really important, and that will continue to be important no matter what we're talking about. If our space travel journey starts on the ground, we have to consider that as one of the very biggest obstacles. And I think Rick's just about to talk to us about things like on-orbit manufacturing, which just totally unlocks a world of almost unimaginable wealth in the solar system, because we can spend all that energy going and doing something rather than just getting 100 kilometers above our heads.
Exactly. Yeah, you've got that funnel, that filter, that choke point of getting to LEO. Once you get there, if you look at a delta V chart of the solar system, as Robert Heinlein said, once you're in LEO, you're halfway to anywhere. You have expended as much energy as it takes to get to LEO. That's as much as it takes to get anywhere else in the solar system for practical purposes.
Give or take, but the thing is, we don't have a Saturn V, or we don't have a Starship, or we don't have an Ariane 5 on orbit, fully fueled, waiting for you to light the candle and put the pointy end towards where you're going.
Because if you were to take that thing apart and strap it on top of other Saturn V's, it'd take you like 20 of those things to get that fully assembled Saturn V up in LEO.
Yeah.
So by having it's the trifecta of cheap, frequent, heavy launch.
Yep.
that's really what does make the change. If it's heavy launch but still expensive, then you don't have that paradigm shift. You don't have the ease of it. You still have to be very parsimonious with how you do this. You still have to say, well, it's super expensive, so you still have to do all this work to shave grams off of your payload. If it's not frequent, then you say, okay, how much of a base can I build with a launch every 2 years?
With one window. And I think that's really key, you know, because that trifecta of factors, when they come together, you can start to ignore current constraints. But if you've only got 2 of the 3 in place, you can't. So a really good example of that is that launch window to Mars about once every 2 years. You know, that's why Elon Musk thinks he needs a fleet of hundreds of starships to go and start a colony there, because he doesn't want to wait 2 years to send more. Well, I mean, he's going to, but he knows there's a critical mass that he needs to get there. So there's the frequency problem that with a launch window to another planet is only impactable to a certain degree. There's the amount that you can put there. But if it's expensive to get a lot up there, then ultimately you're still limited how much you can take. Exactly. It's just going to take you fewer journeys, you know. But this is why reusability is so important. And actually, companies like Skyrora, companies like Black Arrow Space Technologies, and loads of companies that are talking about being eco and green, really kind of deep down, a big part of the reusability and eco drive is the economy, the hard cash of bringing something back and reusing it and not having to rebuild it, isn't it?
For sure. It's the ultimate sort of wastefulness, though, isn't it? I mean, you have some of the most highly machined components that humanity has created. They are high precision, and they are now twisted hulks at the bottom of the Pacific.
Yeah,
it is tremendously wasteful.
Or they're spinning above our heads in a parking or disposed orbit as a second stage.
Absolutely, that as well. That's not the desired fate for these creatures.
No, I agree, and actually, I think maybe this is something that we could explore together, Rick. And for our audience, I think they'll be very interested. You know, people have talked before. Indeed, it's been done before, hasn't it, to use a rocket stage as a space station? And we talk so often about the cost of putting kilograms of man-made stuff in orbit. We've got thousands of kilograms of man-made stuff cutting around in orbit at the moment that is just debris. Lots and lots of companies talking about bringing that back. Some companies now starting to talk about using it in situ, using it in space.
Yeah, well, what was the first Skylab? I mean, it was an upper stage.
It was.
And it's still the largest single module station that's ever gone up. So it's a very viable idea. There's Nanolabs is one of the companies. So yeah, there's lots of companies that are interested in using this stuff, and it's great stuff to use. I mean, it was made as well as could be made. So it contains a volume for sure, and that's pretty much what a space station is. It's a sealed volume. Everything else is just, you know, dials and things to make sure that it stays sealed.
So, I mean, maybe we'll come back to it staying sealed, because space is a pretty hard and harsh environment, and your business is particularly interested in combating some of the negative impacts of that harsh environment. But I remember that we were promising ourselves to start this conversation by talking about space tourism and billionaires. And I mean, the internet is blowing up with people saying this is momentous, or saying this is a total waste of time. It's just billionaires playing. How important is it to getting real science, getting real progress done, to have competing companies putting people in short, a few minutes at a time, hops of microgravity?
Well, you were saying that they're looking at it as the two perspectives. Why can't it be both? Kerbal Space Program is a game, but it is also useful training. It is also learning how to do things that if you go into space and you're running missions, those are useful skills. So for humanity, then yes, it is billionaires playing. But also for humans, children learn a lot of what they do by playing. And that's what this is essentially is. It's kind of stretching your wings. It's kind of testing out how things work. That's what birds do. When they first start to fly, they're not really doing anything sophisticated or directly towards getting food. They're kind of playing.
Yeah.
So
yeah, I couldn't agree more. And also let's just remember, I think there are two really important points here. The first one is this is not public money, and billions of dollars are being spent on this. So some of the people who are criticizing this as billionaires playing are all the same people who quite reasonably criticize national space efforts for wasting money. Let's spend some billionaires' money because they've got enough. So that's one important thing, I think. And then the second thing here is that if I wanted to do some research, or Imperial College London wanted to do some research, or maybe Rolls-Royce wanted to do something, and they're looking at material science perhaps, that relies on micro G to do that science. Well, currently I think it's about $20,000 to go on a parabolic flight on the Vomit Comet, and I think you get 2 or 3 goes at about 20 seconds of microgravity. That's it. That's all you get for your experiment. If you jump on the Virgin Galactic space flights, or you jump on the Blue Origin space flights, you're already bumping that up to 4 or 5 or 6 minutes of micro G. That's a significantly bigger scientific opportunity. That's cheaper than going to the ISS.
They were doing their previous uncrewed suborbital hops. I know people who had missions on the Blue Origin spacecraft. So they got very useful science out of that. And let's go back 100 years to the Barnstormer era, because that is precisely where we are right now, both chronologically and developmentally. So you could say those guys built some really weird airplanes, many of which failed spectacularly, and often with their pilots aboard, pilot/designer/builder/ everything on board. How did they build those? Did they go to the aircraft shop and order aircraft aluminum and rivets and all this stuff that we have today? No. Those were built with like the engine from a Model A, which probably wasn't even a new engine, some spruce and some fabric and some sort of paint to dope the fabric. So they didn't have a fully developed aircraft production infrastructure in place. They had some old World War I surplus aircraft, so there were definitely some Sopwith Camels out there, and some Curtiss biplanes and all that sort of stuff.
But in many ways, those Sopwith Camels and those biplanes, they are the Ariane 5s and Soyuz. They are early spacecraft that could just about kind of do a job. But if you look back on them 100 years hence, you think, wow, that was massively incapable. No offense to these amazing, incredible companies. But in 100 years' time, they will look back on their early spacecraft and they'll say, these really brought us to somewhere important, but they, compared to what we can do now, they were rubbish. And it's the same with the Sopwith Camel. But it did give the new players a pattern to copy. And just as you're talking about these people who are kind of like, hey, I think I might build myself a plane. They thought, well, I've seen a Sopwith Camel. I kind of know what a plane looks like. I'm going to try and build one of those. And Blue Origin's rocket, kind of, it's got some super duper high tech kit on it. But at its basic elements there, it's a rocket in the same way that a Soyuz is a rocket. And a lot of people would probably say that all Blue Origin really needs to do was add more boosters with an OAR. And all the Sopwith Camel enthusiasts need to do is add more struts, and KSB can teach us both of those lessons.
Add more wings.
Add more wings, add more struts, and add more boosters, and I think you're fine.
So yeah, that's pretty much what that is. It's building out the capabilities. So you have this very narrow pool of resources that you can draw from in the space industry. You have a vanishingly small number of people who know how to build rockets.
That's correct.
And a narrow amount of infrastructure such as alloys and sophisticated switching components and all that stuff with which to build the rockets. And by having this broader base of companies that are working on the problem, you get a broader base of everything. You get a broader base of engineers who know how to build a rocket, a whole collection of engineers who know how to build reusable rockets at this point. And they're not necessarily going to stay at the companies where they started. A lot of them are starting their own companies, and a lot of them are joining other companies.
And in this sense, normally when businesses talk about churn and turnover of people, it's talked about as a bad thing. But actually, in an emerging market like this one, it's a really good thing, isn't it? Because all these companies are learning from one another's top secret projects that was 6 months ago. Now all of the companies are starting to import some of these lessons, and they can avoid those ongoing costs and mistakes and risks.
Absolutely. The first time I was in the room with Jeff Bezos, I had a conversation with one of his executives. We were talking about that. We were talking about how all of these employees from these advanced space companies don't necessarily stay there, but when they go away to other companies, they carry their passion and knowledge with them, along with their networks.
Yeah.
And you're going to see, due to the high turnover, you're going to see the equivalent of like a small army of engineers unleashed on the world every 2 to 3 years.
Yeah, for sure.
Not that they're leaving in cohorts, but that's what it amounts to. And
yeah, there's this up rev, to use a sort of slightly engineering term. There's this sort of up rev of general knowledge around how to do advanced manufacturing that just takes this steady drumbeat forward every couple of years of most people having some experience of doing hybrid rocket engines, or most people now have some experience of doing re-entry, for example. These are problems that 3 or 4 years ago, a vanishingly small number of people had ever really looked at. A lot of them probably looked at it through military contracting, and now a lot of people have looked at these problems. And that gets us into discussions maybe for another day. The usefulness of ITAR and what that means for commercialization of space and things like that.
Actually, I do have a little bit to say on ITAR. I understand what it's intended to do, but the end result is it hurts people who are not security threats. I actually have a friend from India who recently had to go back to India because she was trying to work in the U.S. space industry, but couldn't quite pull it off because of the ITAR stuff. And
yeah.
It's really hard. It looks like she's probably going to get a go at Canada, which is good for Canada because I know quite a few people who have ended up there, and they're not people that you would consider threats. They're not, granted, I don't know what a spy looks like. You don't know what a spy looks like, but they're not the sort of people that you would target if you were a nation state that's trying to gather intelligence clandestinely.
Yeah,
or at
for
least
sure.
they're no more of a threat than I am. If you wanted to do the typical route of bribery, blackmail, or ideological leanings, you can screen for that through the normal ways that you do for background checks and all that sort of stuff. You pay attention to what the individual's finances have looked like, do look like, and look like going forward. You pay attention to any sort of weird ideological leanings they might have. You look at any sort of blackmailable things that there are on them that no one knows about. Everybody loves hiding their dirty secrets, and they'll go to extraordinary lengths to do that sometimes.
Indeed, and actually this is interesting, isn't it? Because both of our countries have very well established protocols in place for vetting people who are domestic. But the fact that you were born in a country, we have learned time and again, doesn't necessarily mean that you're aligned. It doesn't necessarily mean that you're trustworthy. So our vetting processes have to be pretty good, and they are pretty good. In the UK, our version of that's called develop vetting. I can't remember what it's called over in the USA, but it provides a similar level of certainty that someone can be trusted, and that's trusted all the way to a sort of above top secret level, for day-to-day working, which is a lot of trust. What's to stop your friend from India going through develop vetting or something similar to demonstrate a trustworthiness? It doesn't seem reasonable. I think in this globe where nation states are becoming less and less dominant as powers, it seems to me less and less likely that a great talented engineer who happens to be born somewhere else will have a great and wonderful and useful career in the United States solely for the purposes of actually funneling information back to their own burgeoning weapons industry. That seems strange to me. China may be a different example because it's literally legal to steal outside of China.
I believe that is its own case, its own specific case, and that's partly because the party leans so hard on its expats. So if I was a Chinese kid and I came to the U.S. and I studied and somehow I got a job at SpaceX and I'm learning all this stuff and I'm doing my best, somebody is going to show up and say, "Hey, so you've still got some aunts and uncles and cousins and whatnot back home. I bet your nieces and nephews would love to have an opportunity to go to a great university when they get older. But if you're not helpful to us, they will never get that opportunity."
Yeah, for sure. Yeah, I think it's difficult, isn't it, to predict what a regime like the CCP is going to do. That they're famously unpredictable, which is why people treat them as an adversary. We I'm sure our audience, both sides of the pond, will be split on this as to whether China is a real threat or not. We've both spoken about it at length before, so I know our personal opinions. But to be fair, because they're just so different and they operate in such a different way to the way that our system operates, it's not wrong for companies to view that as a threat to their modus operandum.
It would be a logical assumption to say that is something you need to be concerned about.
So let's take that one step further then, if we can. Tiangong, obviously now being built in orbit, China's answer to the International Space Station, quote unquote. What is it? Is it a threat? Is it an opportunity? Is it both? And what does that mean for, not just headline things like building space stations and sending capsules with astronauts there to do life sciences experiments, but what does it mean to businesses like yours?
So in the most specific and broadest sense possible, it is sovereign territory. And that's easy enough to say, well, sovereign territory just means nobody else can set foot on it. It is ours. It belongs to us. But looking at what sovereign territory means to the CCP in the Pacific might give you pause as to what it might mean in space, or at least from their perspective. So that is definitely a concern. I expect to see, well, could we say a Spartan League and a Delian League? And I'm not sure quite which is which. I expect to see a whole parallel infrastructure of everything that is either Western aligned or CCP aligned.
Lunar Village, great example.
Yeah, like like in the TV show Space Force. I think by the finale, they had basically traded villages because they both went to attack each other's villages.
Exactly.
And found out that they were all gone at the same time. So yeah.
So this is actually an interesting point, because again, something maybe our audience may not be as familiar with as you and I are. The militarization of space is perfectly legal. It's completely legal to put projectile weapons in space. Countries like, let's be honest, the United States and China and Russia have put projectile weapons in space, and India have put weapons in space. They've tested them. Some of those countries have created quite a lot of debris and damage in those tests, China being among that number. So that threat it's a real thing, the militarization of space, not just the cyber element of it or the denial element of assets, but actual kinetic fighting is possible in space, and it is legal in space. The only thing that isn't legal in space is weapons of mass destruction. But then China didn't sign up to the Outer Space Treaty, did they? So who knows?
Yeah, because we're in a unique patch of history.
So, with all the uncertainty around what the utilization of space is going to look like in 5 or 10 or 20 or 50 years' time, one of the things that we know is true at the moment is that downlink capacity is limited to the Earth, and it probably always will be. And we know that the latency added by coming back to a sort of cloud based on here on Earth, as missions become more complex, more distant, more ambitious, will impact on mission effectiveness. Businesses like yours are there to put that computing power above the cloud in space with those missions. Does this threat profile that we've just described simply add to your business case for putting the computing where it's needed?
Absolutely. It turns every place where you can collect information, it can turn every one of those into a node that not only has an eye, but it has a brain behind that.
Yeah, it's not a data point, it's an influence point.
Yes. It can contribute to making the best decision possible. It can gather more information than what would otherwise be possible. You can have 100 eyes on an asset instead of just one. So you can see it from all the different angles. You can see it from every piece of the spectrum. You can see all its emissions. You can see everything. You can do a much better job of projecting what's going to happen into the future. So, yeah, definitely having the farther we get into a what I call a fully developed space infrastructure, the more crucial compute on station becomes.
Yeah, I think that looks very clear, and I think that's an easy forecast to make. You're in absolutely the right place. So moving that data around once it's been processed on site, moving and then using that data becomes the next major critical obstacle. And in an environment where there's threat, being able to trust the encryption of that data becomes fairly important as well. Obviously, giant leapers are going to be aware that quite recently Arqit sort of came out of stealth mode. They're looking at quantum encryption, sort of unbreakable quantum encryption. When I was speaking to their CEO, he was explaining to me that it's less than 200 lines of code that go on the client unit. It could go on your mobile phone, and you would have mathematically unbreakable encryption straight away. That sounds really, really powerful to be paired up with a business like yours.
Yeah, and that's really what we're trying to do by offering state-of-the-art compute capabilities. You can also run state-of-the-art software.
Yeah.
So instead of having a customized solution that is very much made to fit, made to order, we're enabling a generalized solution that allows the use of customized software. So yeah, it's definitely I feel pretty good about our architecture in terms of future proofing.
Do you think that as the utility of space moves forwards, it's going to rely even more heavily on computing, i.e. through the use of AI controlling activities?
It's inevitable. It really is inevitable. The hardest thing to support in a space environment is the person. We're squishy, we don't like radiation, we like to breathe, and we generally like to eat food. There's always going to be a shortage of people to do things in space. You're never going to have enough crew to do all the stuff necessary. So automation is definitely going to play an outsized role from the get-go.
Yeah.
And that means intelligence.
Yes. No, I think that's true, isn't it? Because, again, to make another Kerbal Space Program analogy here, you spoke earlier about perspective. Well, anyone who's tried to dock manually in Kerbal Space Program knows the value of more than one data point, more than one eye in the sky, more than one perspective, because those two docking ports can be perfectly lined up, and then the next thing you know, you've missed by 15 meters because your perspective was this
in one axis.
So you quickly learn to dock by just constantly moving the camera around, and it's essentially a game of panicking whether you've looked at enough angles that these things are actually gonna mate together quite nicely. And I think that's probably true of the way that we're going to develop things like AI going forward is, well, are we giving this AI tool enough perspectives that it can understand its environment, which is an environment that, to be fair, we, even as humans, we don't fully understand what it means to go and commercialize space. So I think, everyone, we should probably leave that there. I think we should talk about using the stuff that's in space, because what a beautiful dovetail that'll be into the next episode. Next time we chat, so we'll pick that up. We'll pick up space debris and no doubt about 500,000 other super interesting topics.
Sounds good. Looking forward to it.
Well, I really, really appreciate your time. I've really enjoyed that. I hope that the audience has enjoyed it, and I hope that you've enjoyed it too. And we will speak to you all next time.
Cheerio.